has a curve.
Down here and
It's going to go to the coefficient of restitution.
uh-oh.
What?
1 o'clock.
Where's the slate?
Yeah.
With enough time to make my sandwich and eat it.
Come on.
You can borrow my automobile if you like.
No, it's okay. It'll be faster on my bike.
Okay.
Yeah, you need to be over there at the engines lab.
Do you really think they need me? No, they don't. You know they don't. They don't want me there. All I make is smart ass comments.
How hard was it to drill into the, do we have it yet?
No, I don't know what his error is.
How hard was it to drill into the sides of
The only
Oh, I know what the problem is.
it's not on.
Yeah. The classic problem.
do you want a higher resolution camera?
Nah, this is just refining the angle.
Oh, that's all?
Yeah.
Okay, so you're not actually like recording it and
Nah,
Okay.
it's just
I literally
Well, that's a nice flow. Who came up with that?
yeah, it's pretty good.
this guy's 720 if you want it.
This guy's 722.
Oh, it is? Okay, never
Yeah.
mind then. Drilling the holes in the sidewalls weren't too bad for the 1/4-inch holes, but we had to do the 1/2 millimeter holes, and those I broke probably 12 to 15 bits.
We're gonna have to wait a while. Like the scale can't zero because it's never at a constant value. But I can show you some data that I've already taken.
Okay.
Let's see this one.
We're getting some spurting now from
Yeah. So the problem right now is it's not concentric, the two valves. My machining prowess, and also there's sort of some surface texture. So the next, Josh is helping me make the next one, and it looks a lot. This one's like a 25 degree, and the next one is going to be steeper. Definitely more concentric. It's all CNC'd. And then the next version too is going to have a clear pipe, so I can sort of gauge where the that cutoff pressure is. Because I have no idea right now where it is. I can't see the sand level, you know.
Right. And it fluctuates
I
like
didn't
that.
pull the text files off that computer
It's
yet.
either really low or it's still in that realm where
Open it up a little more. It's got quite a range on it.
what's that?
It's got quite a range on it.
There we go. Now we're talking. Nice.
Bagel with avocado.
A what?
Off a bagel.
A bagel with avocado.
Bagel cotto.
Not a bagel.
Yeah.
Bagel.
I thought you said without a cow. And I'm going, what?
Bagel without a cow. Yeah.
So that's my data at steady state. Every one of those things is an avalanche. And then
That's great.
and I also have plots of the just the avalanches themselves. There's their size. Oh, I don't like that.
Whoops. Oh, crap.
So there's this sort of avalanches as they occur. This is the first avalanche that occurred up to the last one, and that's their magnitude in grams for the last test that I ran.
So 1 to 8, and it's linear.
Yeah, pretty linear. What's interesting is that sort of, I don't know if I see it, but to me it looks like there's two bands about which you get a lot more.
Yeah,
So there's like a size that it wants to go at.
one or the other.
And then if
Yeah,
you,
I can kind of see what you're talking about.
because if I look at, what the hell is this plot called? Exceedance rates. Okay. So if I do this plot, I can make the exceedance of it.
A what?
An exceedance plot, so just
What's a cadence?
exceedance. So I normalize the results, I divide it by the largest magnitude pretty much, and it comes out in a power law looking thing.
That's beautiful. That's what we're talking about.
And so this one has the second E, but usually they're a lot better fitted to a power law than look really power law, but they've got this knee here.
It looks, it's doing this.
Yeah. So I think those are the two bands. Is why the data clumps around the two bands. Is why I think, because there's a lot more data there than in the middle or on either sides of them.
Interesting.
Yeah. But so the experiment. I take 10,000 data
So
points.
this is height or count?
That's the probability, I guess. So you got a lot higher probability of having a smaller avalanche than you do for a really big one.
Yeah.
So yeah, that's percentage, I guess,
Right.
probability, exceedance probability.
Yeah, okay. I get it.
But this is for a third of the experiment, so I need to put the rest of the data points in it because every experiment lasts, or the DAC collects data for about 500 seconds, but I like to run it 3 times in a row just because the first third, all it does is grow to the steady point, and then I want to have 2 steady state stuff, so I've got to throw the other data points in there, which I do in Excel, and this computer doesn't have Excel, so I don't like to do it on this computer.
This computer doesn't have Excel?
No, it's Ubuntu and Linux, so it's got like Open Office and that sort of stuff.